Welcome, space enthusiasts! Today we delve into the mysteries of the seventh planet from the Sun, Uranus. This celestial body, named after the Greek god of the sky, is the third largest planetary radius and fourth largest planetary mass in our solar system. Its discovery was quite groundbreaking. Why, you ask? Well, it was the first planet found using a telescope, a feat accomplished by Sir William Herschel back in the 1800s. Positioned beyond Saturn, Uranus is known for its unique blue-green color, a result of the methane in its primarily hydrogen and helium atmosphere. But that's not all. It has a unique tilt and a peculiar rotation that sets it apart from its planetary siblings. So hold on tight as we venture into the cold, distant reaches of our solar system. Strap in as we journey to this distant and unique member of our cosmic neighborhood. Our journey begins in the 18th century with Sir William Herschel. A talented astronomer and composer, Herschel spotted Uranus in the night sky on the 13th of March, 1781. Initially, he believed it to be a comet. However, after further observation and consultation with his peers, it became clear that this was no ordinary celestial body. It was, in fact, a new planet. The naming process of this newly discovered planet was far from straightforward. Herschel, in honor of his patron, King George III, proposed the name Georgium Sidus, or George's Star. However, this name was not favored outside of Britain. After much debate, the planet was finally named Uranus, after the Greek god of the sky, establishing the tradition of naming planets after Roman deities. Thus, Uranus, the only planet named after a Greek deity, was introduced to humanity. Uranus certainly stands out with its unique tilt and rotation. Unlike its planetary neighbors, Uranus spins on its side, showcasing a dramatic tilt of about 98 degrees. No other planet in our solar system presents such a severe tilt, making Uranus a fascinating subject of study. This tilt is believed to be the result of colossal celestial collisions that occurred billions of years ago. It's not just the tilt that's unique, however. The planet also rotates from north to south, a peculiar east-west rotation that's different from most other planets, which have a west-east rotation. This unusual spin results in Uranus's poles experiencing 21 years of continuous sunlight during summertime, followed by a long 21-year winter of darkness. It's an extreme seasonal change, unlike anything we see on Earth. So, this extreme tilt and unusual rotation give Uranus its distinct seasonal changes. Beneath its tranquil blue-green facade, Uranus holds many secrets. It's a world unlike any other in our solar system, composed mainly of hydrogen and helium, with a dash of methane thrown into the mix. But it's this dash of methane that makes all the difference. Methane is a fascinating molecule, capable of absorbing red light from the sun and reflecting back the blue and green light that our eyes perceive as the planet's iconic color. Diving deeper into Uranus's atmosphere, we encounter a layer of icy clouds made of water, ammonia, and methane. Below this, a mantle of slushy water and ammonia surrounds a small rocky core. The interaction between these layers creates a dynamic and complex atmosphere, leading to some truly fascinating weather patterns. So while Uranus might seem calm and serene from afar, don't be fooled. This icy giant has a lot going on beneath its surface. The methane in Uranus's atmosphere paints the planet in shades of blue, giving it a serene appearance. Like its fellow gas giants, Uranus too is adorned with a ring system. But don't be mistaken, these aren't just any rings. Uranus boasts a set of 13 distinct rings, each with its own unique attributes. The rings are thought to be relatively young in the cosmic sense, perhaps not more than 600 million years old. They're composed primarily of large chunks of water, ice, and rock, with a smattering of dark, radiation-altered organic material. Unlike the bright and easily visible rings of Saturn, Uranus's rings are dark and faint, making them a challenge to observe from Earth. They were only discovered in 1977, thanks to the keen eye of astronomer James L. Elliott. Each ring is named after a character from the works of Alexander Pope and William Shakespeare, adding a touch of literary flair to this celestial wonder. Though fainter than Saturn's, the rings of Uranus are a sight to behold. Uranus's magnetic field, much like its tilt, is a study in extremes. Unlike Earth's magnetic field, which aligns closely with its rotation axis, Uranus's magnetic field is skewed at a staggering 60 degrees from its axis of rotation. This unusual configuration leads to a magnetic field that is lopsided, with the magnetic north and south poles opening up into space rather than being neatly centered at the planet's poles. Now, this peculiar magnetic field of Uranus has a compelling side effect: awe-inspiring auroras. Just like the northern and southern lights on Earth, Uranus too has its radiant light shows. These auroras are caused by charged particles from the sun colliding with the planet's magnetic field, creating a dazzling display of lights in the planet's atmosphere. This unique magnetic environment makes Uranus one of the most fascinating planets in our solar system. Uranus's family includes 27 known moons, each with unique characteristics. These celestial bodies orbit the planet, adding a layer of complexity to Uranus's already intriguing makeup. Among the most notable of these are Titania and Oberon, the largest two moons of Uranus. Titania, the largest, has a diameter about half the size of our own moon, and is believed to be composed largely of equal parts water ice and rock. Oberon, not much smaller than Titania, presents its own mysteries, with a surface marked by craters and a possible liquid ocean beneath its icy surface. In fact, many of Uranus's moons are named after characters from the works of William Shakespeare and Alexander Pope, a testament to the timeless influence of literature and the arts on the sciences. These moons add another layer of intrigue to the planet Uranus, each one a world worth exploring in its own right. The only spacecraft to visit Uranus is NASA's Voyager 2. Launched in the late 70s, Voyager 2 was on a grand tour of the solar system, and in January of 1986, it made a close flyby of the seventh planet from the Sun, Uranus. The spacecraft beamed back stunning images and invaluable data about the icy world, providing us with our first and so far, only up-close look at this distant planet. Voyager 2 discovered 10 new moons orbiting Uranus, 2 new rings, and a magnetic field that was both stronger and more oddly oriented than scientists had suspected. Its instruments also confirmed that Uranus's atmosphere is primarily composed of hydrogen and helium, with a small amount of methane that gives the planet its blue-green hue. Despite the many years that have passed since that historic flyby, the data from Voyager 2 continues to inform and intrigue scientists today. The Voyager 2 mission remains our closest encounter with Uranus. Unlike its cousins Jupiter and Saturn, Uranus is classified as an ice giant. This title may conjure images of a planet made entirely of ice, but it's not quite that simple. The term ice giant refers to the composition of Uranus, and it's not all about water ice. So what makes an ice giant an ice giant? It's all about what lies beneath the surface. While gas giants like Jupiter and Saturn are primarily composed of hydrogen and helium, ice giants like Uranus have a different composition. Their interiors are dominated by heavier volatile substances, often referred to as ices. These ices include water, methane, and ammonia, which exist in high-pressure environments in a dense, hot, slush-like state. It's this icy mix that gives Uranus its distinctive blue-green hue. But don't be fooled by the term ice. This isn't the kind of ice you'd find in your freezer. In the extreme pressures and temperatures of Uranus's interior, these substances behave very differently from how they would on Earth. In fact, the core of Uranus is a scorching, hot mass of rock and metal, surrounded by a mantle of these exotic ices. Now you might be wondering, why does it matter if Uranus is an ice giant or a gas giant? Well, this classification is crucial for understanding the diversity of planets in our solar system and beyond. It helps scientists piece together the puzzle of planetary formation and evolution. By studying Uranus, we can learn more about how planets are made, what they're made of, and how they change over time. So while Uranus may be a bit of a misfit among its gas giant siblings, its unique status as an ice giant makes it a fascinating subject of study. It's a reminder that our solar system is full of surprises waiting to be discovered. This classification helps us understand the diversity in our solar system. Peering beneath the clouds, we find a diverse internal structure. Uranus, like its fellow ice giant Neptune, is composed mostly of heavier volatile substances such as water, ammonia, and methane. These substances form a thick, slushy mantle surrounding the planet's core. The core of Uranus is relatively small, made of rock and metal, and amounts to less than 20% of the planet's mass. Above the mantle, we find an atmosphere composed primarily of hydrogen and helium, with a smattering of methane lending Uranus its distinctive blue-green hue. But here's the twist. Uranus doesn't have a solid surface like Earth or Mars. Instead, gaseous and liquid layers transition smoothly into each other, creating a continuum from the upper atmosphere down to the core. This means that if you were to dive into Uranus, you would simply sink deeper and deeper into increasingly dense and hot layers of gas and liquids. The lack of a solid surface makes studying Uranus's interior a fascinating challenge. Uranus's extreme tilt results in dramatic seasonal changes. Imagine a world where the North Pole points almost directly at the sun during summer, basking in constant sunlight for 21 years. Conversely, it plunges into a 21-year-long winter night. That's Uranus for you. This unusual tilt is believed to be the result of a colossal collision with an Earth-sized object long ago. The planet's extreme seasons have a profound effect on its weather. As sunlight reaches the poles, it heats the atmosphere, creating gigantic springtime storms. These storms are so powerful that they can be seen from Earth with the help of a telescope. In contrast, the long, dark winter freezes the atmosphere, creating a calm but extremely cold environment. Uranus's tilt and its slow orbit around the sun also result in an extended period where the sun barely rises above the horizon, much like the twilight zone on Earth. These changes create some of the most extreme weather in the solar system. How does Uranus stack up against its fellow gas giants? Let's delve into this. Unlike Jupiter and Saturn, the behemoths of our solar system, Uranus, along with Neptune, is classified as an ice giant. This is due to its distinct composition, with water, ammonia, and methane ices making up a significant portion of its mass. Jupiter and Saturn, on the other hand, are composed primarily of hydrogen and helium. Now let's talk about color. While Jupiter is a banded ball of orange, brown, and cream, and Saturn sports a golden hue, Uranus stands out with its striking blue-green color, thanks to the presence of methane in its atmosphere. In terms of ring systems, while Saturn's are wide and easily visible, Uranus's are narrow and dark, composed of tiny particles of ice and rock. So in essence, while Uranus shares some similarities with its fellow gas giants, it also has unique attributes that make it an intriguing object of study. Each gas giant, including Uranus, holds unique features that set it apart. What does the future hold for our exploration of Uranus? As we venture deeper into the cosmos, Uranus stands as a compelling destination for future missions. With its unique tilt, potent magnetic field, and icy composition, this planet offers a wealth of knowledge waiting to be unlocked. In the coming decades, we might witness space agencies around the globe setting their sights on Uranus. These missions could deploy orbiters, landers, or even drones to study the planet's atmosphere, magnetic field, and its intriguing moons. The quest to understand Uranus might also reveal new insights into the formation and evolution of our solar system. Moreover, Uranus's ice giant classification piques interest. Unraveling its icy mysteries could redefine our understanding of planetary science and potentially the hunt for life beyond Earth. As we stand on the precipice of these exciting explorations, one thing is certain: the mysteries of Uranus await future explorers. Ready for some fun facts about Uranus? Let's delve into the realm of the intriguing and lesser known. Did you know that Uranus spins on its side? It's a unique planetary quirk that results in an unusual seasonal cycle. Each pole gets around 21 years of continuous sunlight, followed by 21 years of darkness. Now here's a slice of astronomical trivia. The name Uranus wasn't universally accepted until nearly 70 years after its discovery. In fact, it was initially named Georgium Sidus in honor of King George III of England. And what about Uranus's moons? They're named after characters from the works of William Shakespeare and Alexander Pope. Quite the literary connection, wouldn't you say? Lastly, despite its icy blue appearance, Uranus isn't the coldest planet in our solar system. That title goes to its neighbor, Neptune. Uranus, despite its distance, remains a source of intrigue and fascination. Our journey to Uranus has been nothing short of extraordinary. We've navigated through the icy rings and explored the mysterious moons of this enigmatic planet. We've delved into the peculiarities of Uranus's orbit and rotation, which result in its extreme tilt and unique seasonal changes. We've examined the blue-green color of its atmosphere, a result of the presence of methane, and the intriguing characteristics of its magnetic field and auroras. We've compared Uranus with other gas giants, underscoring its unique features that make it distinct within the solar system. We've also ventured into the future, speculating on the exciting possibilities of further exploration and new discoveries that could change our understanding of this ice giant. And of course, we've sprinkled our journey with fun facts and trivia, making our exploration all the more engaging. Keep exploring, keep questioning, and remember, the universe is at your fingertips. Before we sign off, a quick request. If you've enjoyed this voyage through the mysteries of Uranus, don't keep it to yourself. Give us a thumbs up and hit that share button to spread the cosmic knowledge. And don't forget to hit subscribe so you won't miss out on our future explorations. Your comments and questions help us create content that quenches your curiosity, so feel free to drop them below. Thank you for joining us on this cosmic journey. Until next time, keep looking up.